We're now going to look at the last of our index laws, which is our fractional power. So basically, when the index is a fraction, then we can change from this form to this form. Now, what we need to make sure we're doing when we're changing from our fractional index form to our root form is we make sure we understand where the m and the n go. Now, there's an easy way to remember this, and hopefully this will help you. Now, what you've got here is a picture of a plant, and it's just to remind us of the roots. So the roots of a plant are at the bottom of a plant, and that's something I think we'd all remember. So when I get this fractional form, x to the m over n, and we'll write it out here, so I've got x to the power of m over n, and I want to turn that into the root form. I'm going to do the root, and I'm going to put an x. I need to know which way around to put my m and my n so I don't get confused. So if you can remember that the roots of a plant are at the bottom, or roots belong at the bottom, then the bottom of the fraction is the root. So the bottom of this fraction is n, so therefore it goes in here, and it's the nth root. And that means the power at the top must go up here. So basically, if I can remember, the root part of the fraction is the bottom, because roots belong at the bottom. Now we're going to look at a few examples, and there's a couple of different styles of examples you could possibly be asked here. So let's look at the first style here. So we've got example A, the cubed root of x squared multiplied by 2 root x. Now there's a couple of things about this root x we need to understand before we start. When you see the square root of x, it actually does have a couple of hidden numbers. We don't usually write this, but if you look at the square root part here, there is actually a hidden 2 that sits in this space here. We don't generally write that when we do the square root. We also know that this x is actually x to the power of 1. And again, we wouldn't normally write the powers on a number if it's to the power of 1, we would leave it blank. So whenever you see the square root symbol, remember there is a hidden 2 there and there is a hidden 1 there, and that will help us to do this question. So the first thing we're going to do is I'm going to change these into fractional index form so I can then multiply them using my multiplication rule. So let's start off with this one. Okay, we've got the cubed root of x squared, so let's start off by just writing out the x underneath it. And it's going to be a fractional power, so I'm going to put my fraction bar here. And remember, I've got to work out which of these two numbers goes where. So I've got the 3 and the 2 now. Remember what we said, the root part here is the 3, so the roots belong at the bottom, so that's going to be 3 at the bottom. So that's the cubed root there, and the 2 therefore goes at the top. So this x, cubed root of x squared is actually exactly the same as x to the power 2/3. We're going to do the same with this one here. This one has a 2 multiplying it, so we're going to put in the multiplication sign and the 2. And then we're just going to focus now in on this part here, and we're going to change that into a fractional index. So we're going to do the same thing. We're going to write in our x, so x, and we're going to put our fraction bar in because we know when it's got this root, it's going to become a fractional index. And again, we've got the 2 and our 1, we need to get in the right place. So the bottom of the fraction, remember, the roots belong at the bottom. So the root is the square root, so the 2 goes at the bottom of the fraction, and therefore the 1 goes at the top. And that's a useful one to know. Now, we're not quite finished this question. What we still need to do is we actually need to multiply these together. So this is using our index laws. When we multiply two indices together, we add the index numbers together. So let's remember there's a wee hidden 1 in front of this x here. So let's do the 1 that's hidden here times this 2 is going to be just 2. We're going to put our x in, and then we're going to work out what our power is going to be. Because we're multiplying, remember, we're adding 2/3 and a half. That's not particularly easy, so let's go to the side and do 2/3 plus a half. Now, we need a common denominator here. So lowest common multiple of 3 and 2, the lowest number in both times tables is 6, so that's my new denominator. And then I say, well, I multiply the bottom by 2, so multiply the top by 2, so that's 4/6. And then I multiply the 2 by 3 to get 6. So because I've multiplied the bottom by 3, I multiply the top by 3 to make sure it's still equivalent. And then adding them together, nice and easy, 4 plus 3 is 7, so that's 7/6. And what I can do is I can then go and put that back over here as my power 7/6. Now for this bit, it's important to understand that generally you don't always want to use this rule just because you see a fractional index, okay? So generally I'd only change from the index form, which is the form like this, into root form, which is the one with the square or cubed root or whatever in it, when evaluating numbers to a fractional power. So just because this one has x to the power of half times x to the power of 3/2, What we don't necessarily want to do is make these into root form. So just because we see a fractional power doesn't mean make it into a root. For this one, I would just use the first law of multiplication, which means a half plus 3 over 2. So that's a half plus 3 over 2 is 4 over 2. So that's x to the 4 over 2, which would just simplify to x squared. So here we had fractional index numbers, but we didn't actually go and use the rule we've just looked at. It was much better to go and do this. However, examples like this will be much more common. So if you've got a number to a fractional power and you're asked to evaluate it, that's one you would want to change into root form. So this 8 to the 2/3, we'll write out the 8 first. And again, remember, we've got here a fractional index, so it's going to become some sort of root. We don't know what kind yet. And then we're going to look at the bottom, because remember, roots belong at the bottom. So the bottom of this fraction is 3, so the 3 goes in there. So that's the cubed root, and therefore the 2 goes in as the power. And I've got to then evaluate this. Now, we'll start off with the cubed root of 8. So 2 times 2 times 2 is 8. In other words, 2 cubed is 8. So the cubed root of 8 is 2. So what I've actually done there is I've worked out that this part here is 2. Now, what I've actually used up here in terms of the working, I've done the cubed root part and I've dealt with the cubed root of 8, but you'll notice I've not actually yet dealt with this little squared sign here, so that should still appear down there. So that'll still actually be 2 squared. In other words, I've only done the cubed root of 8, I've not dealt with this squared sign yet, so it's still there to be used. Once I've got that though, 2 squared is just 2 times 2, so that becomes 4. And we'll look at a few examples like that on the next slide. So these are all examples where you're asked to evaluate some number to a fractional power. So let's start off with this 16 to the power of 3 over 4. Again, the very first thing we're going to do is we're going to write out equals 16. And because it is a fractional index, I'm going to put my root sign, and then I'm going to decide what numbers are going to go in around that. Now, remember, the roots are at the bottom, so the bottom of the fraction is a 4, so that must be the root. So that goes in there. That makes this the 4th root of 16. And then the other number 3 must be the power at the top then, so that's 3. Now you've got an option, you can actually do it either way around, but one would give you a massive number and we don't really want to do that. So if I try to do 16 cubed, that's going to be a huge number, and then trying to find the 4th root of that's going to be quite difficult. Whereas finding the 4th root of 16 first, that's quite easy. Okay, so 2 times 2 times 2 times 2 is 16. So the 4th root of 16 is equal to just 2. Now again, all I've actually dealt with at this point is I've dealt with the 4th root of the 16, but I've not actually dealt with this cube yet. So that still should be there on this line, so it'll be 2 cubed. Now 2 cubed just means 2 times 2 times 2, so that's 2, 4, 8. So 8 is the answer to that. So when you see this 16 to the power of 3/4, it's actually just 8. We'll try the next one. Again, we're going to write out the number first, 125. And what we're going to do is we're going to put a root over the top of that. And then we're going to decide if any numbers need to go in there. So again, the bottom of the fraction, just like the bottom of a plant, that's where the roots belong. So the 3 is at the bottom, so 3 is the root. So the 3 is going to go on my root sign here, so it's the cube root. And the other number at the top, that 2, will go on as a power here. Now again, we don't want to square 125 and then try and cube root that. Much easier to cube root 125. When you're dealing with roots, it doesn't tend to be big numbers that they're going to give you, especially because you're going to probably be doing this in a non-calculator paper. The cube root of 125, just try, I mean, you might think, well, it's probably going to be 5, but if in doubt, try 2 times 2 times 2, that's not 125, 3 times 3 times 3, that's 27, 4 times 4 times 4, that's 64, 5 times 5 times 5, that's 125. So the cube root of 125 is 5. Basically, it's never going to be a big number, so you're not going to have to do many of them to get it right. Again, here, we've only done the cube root of 125. We've not touched this squared sign yet, so that should still be there because we've not used it yet. So we're going to put that back on. And then 5 squared is just 5 times 5, which is 25. Now, occasionally you're also going to get a substitution question. So evaluate here x to the 3 over 2 when x is 9. So the very first thing I'm going to do there is I'm actually just going to change that x into a 9. So I'm going to rewrite that as 9 to the power of 3 over 2. And then I'm going to do the same thing. I'm going to write out the 9 with a root above it, and I'm going to work out which numbers might need to go here and here. Again, the bottom of the fraction, okay, the bottom of a plant is where the roots are, so the bottom of a fraction, that's your root in here, so that 2 will go in there. In other words, that's the square root. Now, I don't have to put that 2 in there. The root sign on its own is the square root, but it's not a bad idea just to pop it in anyway. And then the other number is going to be the power, so the 3. Now this one's a little bit easier to do in our head because we're doing the square root first. The square root of 9 is just 3, so that's equal to 3. And again, just be really conscious that at this stage, you've only done the square root of 9. You've not gone anywhere near this cube yet, so that should still be there. So it's going to come down and sit there. And then 3 cubed is 3 times 3 times 3. So 3 3s are 9, times 3 is 27, and that's my final answer. I'll now give you a chance to try a couple of these yourself. So remember, write out the number and put the root sign over it and work out where the two numbers in the fraction go, and then try and evaluate it. Okay, pause the video here, and when you're ready to try or ready to look over the two examples, press play again. Okay, we'll go through part A first. So part A here, we've got 16 to the power of 3 over 2, so I'm going to write out my 16, and I'm going to put my root sign there because I've got a fractional index. I need to know which number goes in the root part. Remember, roots are at the bottom of a plant, so the bottom of a fraction here, so that 2 will go in there. It's the square root, and again, we don't actually need to write that, the square root. We're going to write it in anyway. And then that 3 there must be the power, so I can put that in this space here. Now, that's quite a straightforward one. We've got the square root of 16 is 4. And again, what I've said each time is just remember at this stage that all you've done at this stage is you've done the square root of just the 16. You've not gone anywhere near this cube yet, so that should still be there. So I'm going to put that on the next line with that 4. And then 4 cubed is 4 times 4 times 4. So 4 4s are 16, and 16 times 4. If in doubt, just do a little kind of calculation at the side. 4 16s are 24. Carry the 2. 4 1s are 4, plus the 2 is 6, so that's 64. So if you can't do that bit in your head there, then there's absolutely nothing wrong with just doing a little sum down the side to do your calculation. We'll have a look at this one as well for part B. We've got 27 to the 2/3. Again, it's a fractional index, so I'm going to write out the 27. And I'm going to put my root sign on and then check which numbers go where. The bottom of the fraction, remember, like the bottom of a plant, the bottom is the root, so the 3 is at the bottom of the fraction. It's going to go in here, and the other number is going to go up here. Now, that's quite easy. The cubed root of 27, and again, remember, just use trial and error if you can't work it out. So is it 1 times 1 times 1, 27? No. Is it 2 times 2 times 2? No. Is it 3 times 3 times 3? Yes. So the cubed root of 27 is 3. And again, as we've said each time, remember, all we've done at this stage, we've done the cubed root of 27. We've not yet touched this squared sign, so that should still be there because we've not used it yet. And then we've got 3 squared equals 9. And that's our final answer.